Welcome to part two of the lesson on linear regression. We ended by looking at scatter data and talking about drawing a line of best fit or estimating a line of best fit for that scatter data, but being careful to make sure to use our line of best fits to interpolate, which is to predict values within the data set, but be careful not to extrapolate, which means to predict values beyond the data set. But we're at the point where we can say, yes, we can approximate a line of best fit, and using a mean point works very well. However, we can still be wrong sometimes. There's only one line of best fit that is the very best one for the data. For example, here we can see scatter data, and there are two approximated lines of best fit. Both of them pass through a mean point right here. So which one is the better model? Obviously, there are many possibilities, but we want to know what the best line of fit is. Which one do you think? If you guessed line 1, you're correct. For this data, line 1 is a better fit. So how do we find the best line of fit? The technique for this is called linear regression. And it goes like this. Let's say we have this green scatter data, and we approximate a line of best fit like that. When we approximate a line of best fit, there is a distance between our line and each data point. That vertical distance is called a residual value. What we do with the residuals is we make those into squares. For example, if this distance here was 3 units, then this would be a 3 by 3 square, which would have an area of 9. Our goal when we find the line of best fit is that when we have all these squares, the sum of all their areas is the smallest sum of areas as possible. So if we can minimize the area of all those squares, then we have found the line of best fit. Because basically what that means is we've found the shortest distance to all the points. That technique is called the least squares regression. So here's how it goes. Let's say we have the scatter data. This is the same data shown in both, but two different equations. So there are two different linear equations approximating that data. So what we do again is draw those lines which represent the residual amounts. This one has two long residuals, and then these points seem to lie almost right on the line, whereas this one has the residuals from every point. Again, those residuals then are made into squares, and our goal is to find this smallest sum of areas. This one has two larger squares. This one has smaller squares, but more of them. So which one would have a smallest sum of areas? I don't know, it's a close call here. But the one that does have the lowest sum of areas would be the best line of fit for this data. Let's try this online following this link. So I'll get you started first, and then I'll have you try the same thing. So here is where the link will take you. Here's some scatter data. What you're going to do is select 3 of these boxes here. First one draws a potential line of best fit. We can then change the slope and the y-intercept by dragging these here. The second square creates the residuals and the squares. So now as you move the slope and the y-intercept, you can see how the squares change. So your goal is to just kind of look at those and try to make the smallest squares. Your goal is to make the line of best fit. So you're trying to make the smallest area of all the squares. The third one here will help you out with that. Click the third one. It gives you the sum of all the square areas. So currently, for those squares, the sum of the areas is 14.1. So let's see what happens when I change this. Let's move this up a little bit. Oh, look at that. My sum is going down. Now I'm going to change the slope. Sum is going down. Okay. What if I change the y-intercept a little bit more? Oh, good. My sum is going down even more. So this is the same thing you'll do, and you'll try to create the line of best fit by changing those values. Looks like I've created a small sum already. So again, pause the video now, follow this link, or put this link into your browser, go through that same exercise by selecting the first 3 squares and try to minimize the red line, minimize the sum of the squares. See if you can find the best fit line. Okay, now that you've tried, let's see if we can find the best fit line. I think I can make it a little bit smaller there, like that. This. I don't know, I feel like I'm close. But the way to check, and maybe you already noticed this, if you were working with this and you click on the last square, it shows you the best line of best fit. There it is. So I can adjust mine and try to go there. Let's see. Change the y-intercept, put the line up, change the slope slightly. It's tough to do it. Okay, I'm close, but I can't get it quite right. Anyway, tried. I'm pretty close. So hopefully you found one close to the actual line of best fit. Let's keep going. That technique again is called least squares regression. Okay, so we're going to go back to data that we may have seen here. It's age versus movies watched. I'm going to go to that example on Desmos, and we're going to show you how to do it on the calculator as well. So a hint for the exam, just so you know, you will be expected to use your calculator to find the line of best fit. So I'll show you that technique in just a moment. But let's go to Desmos first. So here's that age scatter plot, age versus movies watched. Right, okay. So again, we've already gone through this process, but I'm going to move the y-intercept a little bit. I'm going to change the slope to try to approximate the line of best fit. That looks pretty good. I think that looks like a good line of best fit. Also, we found the mean points. So let's see if my line of best fit goes through the mean points. I'm going to find the mean of the x values, which it tells me is 33, and the mean of the y values, which is 13. So now I'm going to enter that point, 33, 13, label it, and looks like my line of best, or the line that I approximated is very close to passing through there. The actual line of best fit must pass through there. So let me change the y-intercept a little bit there to make it pass through. So maybe now the line I have there is the line of best fit, but we don't know for sure. So let's check. This calculator will do a least squares regression for us. So I'm going to set up that least squares regression. The way to do that is, is to use this symbol. Okay, there it has. Oh no, something's not working. Let me close those. Does that work now? Wrong. I have to make this M1 and B1 because I already had used M and B here. So anyway, the red line is the line of best fit by least squares regression. That's the best line. The one I had here is pretty close. So I did a pretty good job of approximating that. Notice they both go through the mean point. So I was close. So that's on Desmos. Now, how do you do this on your calculator? Let's check. Okay, so here's the data. You're going to press on, and of course that number 1 edit, and you're going to enter into list 1 and list 2. I've already done this to speed up the process, so if you need to pause now and enter the data, please do that. Here's our data, list 1, list 2. The next step is to press stat again, arrow over to calc, and we're going to do the same thing we did when we were finding correlation. We're going to go to number 4, linear regression, enter, list 1, list 2, calculate, enter, and it gives us a linear regression here. So last time we were looking at the R value here, and we can see there's a very strong R value. There's a strong positive correlation, but it also gives us the equation up here. We have y equals ax plus b, which is like mx plus b, and it gives us the a and b value. Let's compare those to Desmos values. So it's saying the slope is 0.33, and the y-intercept is about 2.1. So on Desmos, a slope of, oh, there it is, 0.33, and a y-intercept of 2.1. So Desmos and the calculator are giving us the same line of best fit. So everything sounds good. All right, so that's an important skill. Make sure you know how to do that on the calculator. Okay, so now you're going to try that for this one. Here you have some data. The situation here is cars' tires become worn. As a car's tires become more worn, it uses more fuel to travel the same distance. So this table shows the age of the car or the age of the tires, and then the number of kilometers you can travel on 1 liter of gas. So in the beginning you can travel more, and then less and less and less because the tires are becoming older. So use that data, use your calculator, figure out the regression line for that, and then go on to interpret the meaning of your regression line. When it says interpret the meaning of the constant value, it means the b value. For y equals mx plus b, tell us in words what the b value means. For c, interpret the meaning of the gradient means interpret the meaning of the slope, the m value. What does it mean in the context of the situation? And finally, now that you have an equation that can be used to model this data, this scatter data, we can use that equation or regression line to make predictions. So use your equation to estimate the distance the car would travel if the tires were 3.5 years old. Okay, let's check our work. Here's the linear equation or the regression line that your calculator should have given you. And here's the answers for B, C, and D. So B is, let's see, the interpretation of the constant is that the constant was your y-intercept. So that means a brand new car, it has an age of 0, right? The y-intercept is at x equals 0. So a car at age 0 will travel 21.3 kilometers on 1 liter of gas. And then interpreting the meaning of the gradient, well, the gradient is the slope, and the slope is change in y in relation to change in x. So it's how much every year the car travels 1.34 kilometers less on each liter of fuel. So here's our slope of negative 1.34. So again, every year, the amount of kilometers we can get goes down by 1.34. And finally, using the model to find a value, we use it like this. Let's try another question. Here we have the scores marked out of 10 for a class of students in English and TOK. Here's our English scores, here's our TOK scores. Again, use technology to help you find the regression of y on x and then x on y. Let me explain the difference between these two. The regression of y on x is what we've been doing. It's creating a regression line, y equals mx plus b. The regression for x on y is like the opposite. It's saying create an equation where it's x equals something, something, something. You may at first think this is just the inverse equation, but it's not. It's basically like saying if your x values now became the y values, and the y values became the x values. So if you created your scatter plot and changed the x and y values, the regression line for that would be a different line. How you do that on your calculator is you go through the same process of finding the regression like here, except for when you're, let me go to that step, the final step. So stat, when you go to calc, and number 4, linear regression. All right, in here, where it says your X list, it says list 1, list 2. You're going to change those two around. So to get B, your equation of X on Y, you're going to say, oh, my X values are now list 2. And the way you do that is you go second, number 2, which is list 2. And then here, my Y values are now going to be my list 1. So you're just switching those two. So I'm putting list 1 there. And you'll go to calculate, and it will give you a new linear regression line, and that's the one for B. Let's check your work on that then. Okay, here's the two regression equations. Here's y on x, and here's the x on y one. Those are two equations. Here they are plotted on the same scatter data. So that scatter data is here, and we can see the two lines. Now, those lines are used differently. If you need to find out y values when you know x values, you use this equation. If you want to find x values when you know the y values, you're going to use the second equation. So look at the questions we have here and see if you can answer those two, D and E. Okay, for D, we use the first equation because in D it says find the TOK score, which is the y value, if you knew the English score. In E, it's the opposite. It says find the English score if you knew the TOK score. So now we're going to use the second equation. So I hope you were able to figure that out. Good job. You are now a master of linear regression. You know how to find a regression line in your calculator. Please try the practice assignment. It will help you practice all these skills that we've learned today. You can do it.